Hai, Assalamualaikum warahmatullahi taala wabarakatuh, and a very good morning ID to everyone. So my name is Ahmad Farhan bin Muhammad Noor from MTES2. Today I'm going to present to you about Task 2 Continuous Assessment for subject MTES1104 Algebra. Today's topic will be the application of vectors in our daily life. But before we proceed, let us take a look what is vector. Vector is a mathematical object that has magnitude and direction. And for magnitude of a vector, it can be in the form of a small or big value. But for direction of the vector, it can be in the form of degree or the direction of compass. So let us take a look at this sample question. For this vector, the value will be 3 units to east, where the magnitude of this vector is 3 units and the direction of this vector is to the east. So next we are going to have a quiz time for this one question. So I will give you 10 seconds to guess the answer, and then I will pick one name to guess. So I will give you 10 seconds starting from now. So time's up. So I would like to call Zakwan to answer this question.
My name is Zakwan from Maths 1. So the answer will be 3 units to the west.
Yes, exactly. The answer is 3 units to the west. So how can it be? So based on the graphic shown on the screen, we can count the number of bosses in the vector. And the number of bosses in the vector is 3, that represents the magnitude of the vector. And for the direction of the vector, we can see on the screen that it is moving towards west. So the answer will be 3 units to the west. Okay, so next, despite the importance of knowing magnitude and also direction of a vector, we also have to know about vector components. In vector, we have two different components, which are y component and also x component. For x component is a direction of vector that lies in the same direction of x-axis. Besides x component, we have y component, where y component is a vector that lies in the same direction of y-axis. Thus, the importance of knowing vector components is to determine the direction and also the magnitude of a vector. So let's do this. Let's do another exercise. And in this exercise, we are going to find the vector components, determine the magnitude of the vector, and also determine the direction of a vector. As you can see on the screen, this is a lawnmower that is used to mow grass and plants. So in mechanical engineering, it is important to determine the magnitude and direction of a vector in order to find the exact value of force that is needed to move a lawnmower. So from the visual representation that you have seen before, this is the graph representation of the vector that is used in moving the lawnmower. The vector is on the fourth quarter of a graph, and it is written that the vector magnitude of the graph is 300 Newton and the direction of the graph is 30 degree. So first we are going to find force at x component. So by using sin constant principles, we get cos A equals to fx over f. So to find fx, we have to times both sides with f, and we get fx equal to f cos A, where A represents the angle of vector 30 degree and f represents the magnitude of the vector equals to 300 Newton. So we substitute both value in the equation and we get Fx equal to 259.81 Newton. So we have found the force at x component. So now we are going to find the force at y components. So by using the principle of sin constant, we get sin A equals to Fy over F. So in order to find Fy, we have to times both sides with F, and we are going to get Fy equal to F sin A. And A, as usual, represent the angle of the vector, and F represent the magnitude of the vector. So we get Fy equals to 300 sin 30, and then we get 150 Newton. So in this part, the magnitude and the direction of the vector already given, as you can see on the graphic. But we have to reconfirm and recheck the value of its magnitude and also direction. So as the given figure shown, the magnitude of the vector is 300 Newton. So by using Pythagoras theorem, we can recheck the answer. So F equals to square root of fx squared plus fy squared, where fx we have already did before this, which is 259.81, and fy equals to 150, and then we substitute both value in the equation and we get 300.020, which approximately to 300 Newton. So this is proven that the magnitude of the vector is 300 Newton.
Farhan, sorry for disturb you. How do you get the formula of f equal to the square root fx square plus fy square?
So thank you for the question. Actually, this is the slide where the question should be asked, and we use theorem Pythagoras where the hypotenuse is f, and the other side will represent fy and also fx. So the equation should be as shown given. BC square equals to AB square plus AC square. So next we are going to look in the context of this question. If we look back at the graph shown before this, f represents the hypotenuse of the triangle. So the equation will be f squared equals to fx squared plus fy squared. So in order to find f, which is the hypotenuse, we have to square root both sides of the equation, and we will get f equal to in square root fx squared plus fy squared, and continues the calculation until we get the value of f. So I think I have answered the question. So let's move on to the next one. So as I said earlier, the direction of the vector already been given, which is 30 degree. But in order to check, we have to use tan A equals to Fy over Fx, and we substitute the value of Fx and also Fy, which is 259.81 for Fx, and Fy equals 150, and we substitute both value in the equation and we will get 29.999997, which is approximately 230. So this proves that the direction of the vector is 30 degree. Just now we have looked at an example that related to our daily life, and then now we are going to look at the application of vector in daily life for another example. And in this slide, it is about military and vector. A cannon is any piece of artillery that uses gunpowder or other usually explosive based propellants to launch a projectile. Different forms of cannon combines and balance these attributes in varying degrees depending on their intended use on battlefield. So the use of vector here is something that is crucial, because when you want to target something in another field or another area, we are going to use the direction and also magnitude of the vector in order to determine the distance of the propellants. So now is the application of vector in basketball. In sports, we have so much kind of sports. For example, it's basketball, baseball, and also football. And in sports like basketball and also baseball, the players actually are applying the vector indirectly. They shot the target or threw the ball at a direction with specific angle, which is done by using the knowledge of vector. The players should have known the distance between them with the target and determine how much the angle that is needed to target the ball into the goal. The application of vector in terms of boat crossing a river. When a boat is crossing a river, there are two different velocities working simultaneously, which are velocity of the boat and velocity of the river. So the direction of the boat changes with respect to the velocity of the river. So the boatman have to find the angle to cross the river in a straight line to reach the bank of the river. The application of vector here is very important so that the boatman can reach the bank of the river in a straight line, because you cannot move in a straight line directly just like that without have to know the angle that is much easier for them to cross the river. So because the velocity of the river will act perpendicularly to the direction of the boat. Last but not least, the application of vector in terms of crosswind. Crosswind is any kind of wind that acts perpendicular to the direction of the plane. When a plane when a plane came to land, sometimes it faced difficulties because of the crosswind. A pilot can find out the resultant velocity and also the direction by with help of vector. This is because when the crosswind acts perpendicular to the direction of the flight may tend to turn another direction from the original one. So by the using of the knowledge of vector, it helps the pilot to move the flight accurately based on the land. So here we are. Thank you so much for listening. I hope you guys understand what I'm trying to say and hope the best for the future. Thank you so much. Bye.